My name is Shivam Bohra. Welcome to the official channel of CodeChef. In this video, I'll be explaining this problem called as odd GCD, which appeared in Starters 14 2021. The difficulty level of this problem is simple, and the prerequisites are GCD and the lower bound function. So the problem statement says that we are given an array of n integers, and we have to make sure that the GCD of all these array elements is an odd integer, right? So to achieve this, what we can do is we can select an index I from this array. So the element at that index I would be AI. So we have to make sure that this element AI is greater than 1. And if this condition is true, then we can set AI equals to AI divided by 2 and the lower bound of this, right? So we can simply replace this AI value by this value, right? And we can choose an index multiple times during this operation. So we can perform this operation on the very same index multiple number of times, right? So we have to find the minimum number of operations required, after which GCD of all the elements in this array becomes an odd integer, right? Now let's understand this lower bound function, right? So the lower bound of x would simply be the largest integer that is less than or equals to x, right? So for example, if let's say we have 1.5. So to find the lower bound of 1.5, simply ignore each and every digit that comes after the point or that comes after the decimal point, right? So over here we have 1.5. So simply ignore everything that comes after 0.5. So simply ignore this 0.5 from here, right? So our answer is 1. Similarly for 2, we have no point or decimal point over here. So here the answer would be 2. For 7 by 2, firstly, I would convert it to decimal. So we have 3.5. Simply discard all the portion that comes after decimal. So I'll simply remove this 0.5 from here. So my answer would be 3, right? Similarly, if I have 1.9 over here, then I'll remove the 0.9 and our answer would still be 1, right? Now let's see the input and the output format. In the input, the very first line contains a single integer t, which is the number of test cases. And for each of these test case, the very first line of each of these test case would contain a single integer n, which is the size of this array. And on the second line of the test case, we would have n space separated integers, which are simply the array elements, right? And output is simply the minimum number of operations required, after which the GCD of all the array elements becomes an odd integer, right? So moving on to the constraints here, t could be 10 to the power 3, n could be 10 to the power 5, and array elements could be up to 10 to the power 9. Sum of n over all test cases does not exceed 5 into 10 to the power 5, which means that if we add all the value of n's over all test cases, then this would not exceed 5 into 10 to the power 5, right? Hence, a big O of n log n approach or any approach better than n log n would work in this case, right? Now we have 3 test cases over here. In the very first test case, we have 3 array elements, or the size of this array is 3. The array elements are 2, 3, and 5, right? Now the GCD of 2, 3, and 5 is already 1, which is odd. Hence, we need not to perform any operation over here, right? Because the GCD is already odd. Hence, the minimum number of operations required in this case is 0. In the second case, where we have 4 and 6, so we have 2 array elements this time, 4 and 6. So the GCD of 4 and 6 is 2, right? The GCD of 4 and 6 is 2. So you choose the index I equals to 2 and set A2 equals to 6 by 2, right? So I'll choose this array element which is containing 6. So I'll replace this 6 by 6 divided by 2 and the lower bound of this, right? So 6 divided by 2 is 3 and the lower bound of 3 would remain 3, right? So now we have 4 and 3, right? Now 6 would be replaced by 3. So now we have 4 and 3. the GCD of 4 and 3, the GCD of 4 and 3 is 1, which is now odd. Hence, the condition is now satisfied, right? And the number of operations that we performed over here is just 1, right? So the number of operations that we performed over here is just 1, right? Similarly, for the third case, the number of operations required are 2. So now let us move on to the approach. So here we have lower bound functions, and inside these lower bound functions, we can have two kinds of values. That is, either I can have a non-decimal value like 9, or I can have a decimal value like 9.16, right? Now, in the second case, 9.16 would be converted into 9, which is an integer. In the first case, 9 would still remain the same, right? So we can see that in the very first case, this value is not affected by these lower bound functions, right? But in the second case, which is a decimal, this value is affected by the lower bound functions. So if this resultant value is non-decimal, then just like the very first case, this value would not be affected by the lower bound functions, right? Now, AI could either be odd or it can be even, right? If AI is odd, then it won't be divisible by 2. Hence, dividing an odd number by an even number would result into a decimal number, right? For example, if let's say we have 5 and I divide this odd number 5 by 2, then I'll get 2.5. Similarly, if I divide 7 by 2, I'll get 3.5, right? But on the other hand, if this AI is even, like 4, 6, or 8, then in all these cases, if I divide these numbers by 2, then the results would be integers, right? The results would not be decimals in this case, right? So if AI is even, then this result would be non-decimal, Hence, in that case, we can remove these lower bound functions. So if AI is even, then in that case, AI can be rewritten as AI upon 2, right? Now, let's consider a case in which we have only even numbers. So here we have 4, 6, and 8. As all of these numbers are even, hence, we can perform this modified operation for even numbers on this array, right? Or on these array elements. So over here, 4 can be written as 2 cross 2, 6 can be written as 2 cross 3, and 8 can be written as 2 cross 2 cross 2, right? Over here, the common divisor is this 2. Other than this 2, we do not have any other common divisor. Hence, the GCD for these numbers would be 2, right? Now, if all these numbers are even, then we can perform this operation on any of these 3 array elements, right? Either 4 or 6 or 8, right? Now, dividing 4 by 2 simply means that dividing these factors by 2, right? Or dividing 2 cross 2 by 2. So I'll simply remove a 2 from here. Dividing this 6 by 2 means that simply dividing these factors of 6 by 2, right? And dividing 8 by 2 simply means that dividing 2 cross 2 by 2. And in all these three cases, if I divide these factors by 2, I'm simply removing a 2. If I divide this 2, I'm simply removing a 2 from the factors. And over here, I'm also removing a 2 from the factors. So if I perform an operation on any of these 3 array elements, I'm simply removing a 2. I'm simply removing a 2 from the right hand side, right? So tell me, which out of these 3 elements has got the least number of 2's? Has got the least number of 2's? The answer is simple. It is 6. 6 has got only 1 2, right? So I'll choose this number which has got the least number of 2's as factor, and I'll simply perform this operation on this number, right? So now I'll divide this 6 by 2, and now I'll simply remove this 2 from here, right? And now this 6 becomes 3. So the factor of 3 is just 3, right? And now we have no common element. Hence now the GCD would be 1, which is odd, right? Similarly, if we have an odd number, like in this case here we have 9. So this odd number would never have a 2 on the right hand side, right? Or as a factor. So this odd number is not divisible by 2, so it won't have a 2 over here. Hence, the common divisor could never be 2, right? Because this element does not have 2, so the common divisor would also not contain any 2, right? So this GCD would never contain a 2 over here. Hence, this GCD would also be odd, right? So if we have an odd number, in that case, the GCD is already odd. So in that case, the number of operations required is 0, right? So the approach is really simple. Simply find how many times do we have 2's on the right hand side, right? Now, in this case, for 4, we have 2 2's. For 6, we have a single 2. For 8, we have 3 2's, right? Now, whichever out of these 3 is minimum, simply print that count, right? So for 6, I have a single 2. I have a single 2, right? So 1 would be the answer in this case. Simply divide the 6 by 2, and now we would not have the GCD as even, right? Similarly, in this case, 9 does not contain any 2. Hence, the count of 2's over here would simply be 0, right? Hence, this 0 would simply be our answer, right? So now let us move on to the code. So firstly, I'll input t, which is the number of test cases. Then I'll iterate t times. Then I'll input n, which is the size of the array. Then I'll create a vector ARR of size n. Then I'll simply input all the array elements inside this vector ARR. Then I'll simply iterate for all the array elements, that is from 0 till n minus 1. And I'll simply store the count for each array element. That is, I'll simply find the highest power of 2 that divides the array element, right? So initially this is 0. I'll store the array element in temp. I'll check if temp is divisible by 2 or not. So if it is divisible by 2, I'll simply divide this temp by 2, right? And I'll simply increment my count by 1. So this while loop would simply count the highest power of 2 that actually divides the array element, right? Now, after this while loop, I have got the count of how many times or the highest power of 2 that divides the array element. Now I'll simply check if this is the very first element of this array or if count is even lesser than the answer, right? So what this means that if it is the very first element, then this count would be stored inside my answer, right? If it is not the very first element, but then the count of this element is even smaller than the previous count, right? So now I'll replace my answer by this count, right? And after this for loop, I'll simply print my answer, right? So if let's say I have these 3 array elements as 4, 6, and 8. So for this, our answer should be 1, as we can divide 6 by 2. So our answer is 1. And if let's say we have an odd number like 7, so now we should get a 0, right? So here we have a 0. So let's just submit the code. So I'll click on submit. So here we can see that